Hi, this video presents a worked example of the final draft of our vector-based queue. We're going to enqueue and dequeue some elements. The final draft was kind of complicated, so we think it's worth just showing how it actually works with all these details in place. So what we're going to do is show the resizing operation on growth, meaning we're going to fill up the vector-based queue and it will resize itself. We're going to see the wraparound behavior, and this is all with the final draft of the vector-based queue, the third draft. So let's go here. So we're going to start off and do the create empty operation. So that will initialize our queue with front at index 0 and size is 0. Now let's say I enqueue the number 5. So I've got an empty vector to begin with. The resize operation will occur. It will calculate the new size to be the maximum of 2 times the current size, or 1. This is why that maximum is in here. 2 times 0 is 0, but the maximum of 0 and 1 is 1. So it will create a size 1 vector and then increment size to 1 and assign the 5 element at the index number 0, the one and only element of the vector. So here's what the queue looks like after that. Alright, now let's say I enqueue 6. Well, this is going to trigger another resize because the vector is currently empty. The size of the queue is equal to the size of the vector. So the new vector will be created with size, which is the maximum of 2 times the current size, or 1. 2 times 1 makes 2. The maximum of 2 and 1 is 2. So the new vector will be size 2. And from now on, that maximum won't do anything. We'll be doubling the capacity of the vector every time. So the new vector has 2 elements in it. Then we have this loop that copies the queue elements over one at a time. So the 5 gets copied into index 0, and then we're done. So this is what my queue looks like after the resizing. Finally, we still need to add the 6 element and increment the size. So after enqueuing the 6, here's what we've got. We've got a vector with 2 elements in it, and the front is at index 0, the size is 2. Let's say we enqueue 7. Okay, this is going to make another resize happen because the vector is currently empty. We'll calculate the new size, which would be the maximum of 2 times 2, which is 4. The maximum of 4 and 1 is 4. So the new vector has 4 elements in it. These arrows are depicting the copying. That for loop will copy 5 from index 0 to index 0, 6 from index 1 to index 1. So we copy all the elements out of the old small vector into the new large vector. Then they're all copied over. We still need to place index 7 at index number 2 and increment the size to 3. Okay, now let's enqueue 8. This time we don't need to resize. It's nice to have a break from that. And we just put 8 at index 3, increment size to 4, and we're good. Next, let's do a dequeue. So dequeue will calculate the new index. It's the old front plus 1, mod the vector size, which is just 1. So the front becomes 1, effectively saying ignore the 5 at index 0, and we decrement the size to 3. Now let's dequeue again. So same thing happens. We calculate the new front, which would now be 2, and we decrement the size to 2. Let's enqueue 9. So this is to illustrate the wraparound effect. So the index I, where we place the value 9, would be front plus size mod length of vector. So that would be 2 plus 2 is 4. 4 mod 4 is 0. So 9 is placed at index 0. Also, we increment the size to 3. Okay, let's enqueue 10. This is going to show you the wraparound thing again. So if I enqueue 10, we need to calculate where that goes. That would be at index 2 plus 3 mod 4. 2 plus 3 is 5. 5 mod 4 is 1. So at index 1, we place the 10. That's the only available element, and the size is incremented to 4. Let's say we enqueue 11. Okay, this will trigger the resize because the vector is currently totally full. The size is 4 and the vector size is 4, so there's no room, so we need to make a new bigger vector. We allocate a new vector, and its size is 4 times 2 makes 8. The copying is a little bit more interesting this time. So remember that loop starts at the front of the old vector, which would be index 2. So we're going to start at index 2 and copy 7 over to index 0, 8 over to index 1, 9 from index 0 in the old vector into 2 in the new vector, and 10, which was at index 1 in the old vector, into index 3 in the new vector. So this is sort of untwisting the vector. Before it was kind of twisted around because the queue wrapped around. It started at 2, went to the right for a while, then wrapped around to 0. might call that flipped or twisted. This copying operation undoes that, and now the front of the vector is 0 and the elements just go straight around with no flip or twist. So now I'm left with this size 8 vector. The queue has size 4, and the last thing that needs to happen is 11 needs to go at index 4, which is the last element of the vector. Okay, so here's where we'll stop. We went through all those operations and we did illustrate the wraparound effect and also the resize effect.